All right, hello everybody. I was going to go over a little bit how to do this lab if you're having trouble understanding it or completing it. I'm not going to go over most of the questions. I'm just going to go over how to do the graphing part. That's because I want to see what answers you think are correct first. You'll have an opportunity to edit this and resubmit it next week if you don't like the score you got. So I'm going to go ahead and skip over these questions here and just go down to the collecting your data. Of course, if you have any questions about any of that stuff, please email me. I'm just going to do one example on the graph, which is table salt. You also only have to do one example, and you're welcome to do table salt like I did, but I would urge you to maybe challenge yourself and try to do one of these other three. The first thing we have to do is look and see how many mice in our population of lab mice have died at each of these concentrations of table salt, and then calculate the percent of those mice that died. And we made it pretty easy because in all of these mice cages, there's only 10 mice. So the number of mice that died will equal the percent mortality. If we look at concentration 0.0001%, no mice have died. At 0.001%, still no mice have died. At 0.01%, no mice have died. Table salt, our bodies and mice are really good at being able to eliminate excess salt just through urinating or your brain telling you that you're thirsty. So table salt isn't as toxic as you might think. When we get to 0.1% though, we can see that 2 mice have died. So here, our mortality would be 20%. When we get to 1%, 3 mice have died. That would equal a 30% mortality. And when we get to a concentration of 10%, that would mean that in the solution, 10% of what you're drinking is pure salt. 90% of the mice had died. Okay, so going back to our data table here, I'm going to go ahead and fill in what we found out from that experiment. 0 mice were dead at 0.0001%, so that would have a 0% mortality. Same with this one, 0.01. Same with 0.01. Once we get to 0.1%, however, there was a 20% mortality. And so, because there was 10 mice, that would mean that 2 are dead. When we get to 1%, there was a 30% mortality. Since there was 10 mice, that would mean 3 were dead. And when we get to 10%, there was a 90% mortality. Out of 10 mice, that would mean 9 are dead. All right, so now that we have that data, we need to try to estimate what the LD50 is. This is a little bit different in terms of the units. We're doing this in a percent, where in the notes it was typically milligrams per kilogram. We're not going to worry about that too much. I mean, that's what our percent mortality was here. Down here is our graph, and you might notice that's a little bit different than normal graphs that you might be used to seeing, in that on the x-axis here, it's not going up by equal intervals. If you look, the distance between 1 and 10 is the same distance as, say, between 0.01 and 0.1. This is what we call a logarithmic scale, and we use this when there's a wide range in the data. So the first thing we need to do is label our axes. So I'm just going to type in here this little text bubble. Our y-axis, this would be percent mortality. And then down here on our x-axis, this was the LD50 in percent. Okay, so let's start plotting. For these concentrations, you're just going to find them down here. Basically, each big bold line going up is where you're going to plot your data based on the mortality. So for 0.0001%, there was 0 dead and 0 mortality. So I'm just going to put a little dot there. For 0.001%, there was 0 dead, 0% mortality. For 0.01%, same thing. And then for 0.1% is where things start getting interesting. And we had 2 dead, 20% mortality. So here, where it's 0.1, I'm going to go up to where it's 20% mortality. For 1%, it was 30% mortality. So I'm going to find that here between 20 and 40. And then for 10%, it was 90% mortality. So I'll find that here between 80 and 100. Okay, and then let's just try to connect these dots to show the graph in the LD50. It's kind of like the same curve that we're used to seeing. What we then want to do is figure out where 50% mortality is, what concentration that is. So under mortality, we'll go to 50%, which is right here, between 40 and 60. And then we're going to go and see where this line intersects with the graph line. And it happens to intersect right here. If we go down, we can see this is between 1 and 10. If you look at the intervals, there's actually 9 spaces here, 9 lines. So there's, essentially this would be 2, 3, 4, 5, and so on. So this right here, if we're going down, this would be 2. So the estimate for the LD50 in percent for table salt would be 2%. I hope that makes sense, how we did the graph. For practice, you might want to try graphing the other ones as well. If you still have questions about this, feel free to email me. We can talk over email, or we can set up a meeting in Teams, or you can join me at my office hours next week on Wednesday at 10 o'clock. All right, talk to you later.